They saw 2 persons from there.
While Xavi rejoins, can you confirm that you can hear me well and see me?
No, Manisha, we really can't hear you.
We can't hear you.
Okay, that's good.
No, it's absolutely perfect. Very good sound.
All right, great. Okay, so the internet in Montenegro is not too bad after all.
Yeah. Xavi, could you please try your mic? Because Thomas told us there is a game of mic that you...
Hello, do you hear me now?
Yes, very well. Very cool.
Good, now this works.
So it's time, I guess. Non, après, laisse un petit quart d'heure. So this is the 6TISCH working group. So if you're looking for routing over plane in flight, it's the wrong place. Otherwise, we'll start now. And so we are trying this new tool that they gave us. So let's see how it works. So this is a traditional IETF meeting. So all the provisions of the best practices and intellectual property, anti-harassment, etc., apply to this meeting. In particular, if you're aware of any IPR in technical subjects being discussed in this meeting, please let us know or tell the chairs after the meeting. Remember that as an IETF meeting group, everything that's being said is shared, meaning that your presence will be logged, the minutes will be recorded and kept, and people will be able to visualize the meeting after through recording. We'll take the notes, the minutes of the meeting on the Etherpad link. The Etherpad link is on this page here. Please join for 2 good reasons. One, if you have trouble understanding what was said, maybe somebody captured it. That will help you see what was said or fix it. And second, if you say something, come to mic and say something, you may want to check that your words were captured correctly. For those 2 reasons, it makes a lot of sense to join the Etherpad. We will pass on the blue sheets in a few minutes just to give a chance for the latecomers to join the room before we pass them on. And now will be the difficult time of finding minute takers and mostly Jabber scribes. Yes, that's already recorded, and thank you so much. Now we need a Jabber scribe. Oh, fantastic, Raul, you're a lifesaver. You may sit here. Thank you, Raul. Thank you very, very much. Okay, so here are the links for the various materials. We publish the minutes on the IETF site. There is already the agenda published there, so you can click on links to find out all those websites. And with this, let's do the traditional agenda batching. So today we'll spend a little bit of time, not too much, with Xavi explaining us the latest on the 6-stop IESG work. Then we'll have also remote Tang Fei. Oh no, Simon, you're the one talking, right? Simon, you'll come to the mic. So yeah, Simon will be presenting us the merge of MSF. Then we'll have Malisha for minimal security. And Malisha, there has been a lot of activity on minimal. So if you like, we can actually compress the Michael slots, which I intended to present, to give you more time. Would you like to have like 30 or 45 minutes, Malisha?
So, I mean, we have 10 issues to discuss. I don't know how much input we will get and how much time it will take. So, I mean, maybe if we can make this flexible, it will be the best.
Well, ultimate flexible is to put you last. So you have all the time left. But I would not do that either. So say what? I you have 25 minutes, but then I won't stop you if you go to 35 or even 40.
Okay.
At 40 minutes, I will make a hard stop. Okay.
All right. That's good. Good. Thanks.
So then we have two discussions about Michael's draft. He has progressed on both drafts, but he cannot be with us today. So I will be presenting an update. And then time permitting, we'll have Xavi explaining us the latest on global time. Jonathan on multiple files and subgig. And then Yach, we had a very interesting discussion about the way retransmission works on 15.4.2015, and actually Yach extracted the operation in a way that we can now understand. So if we have time, Yach will present that to us, and thanks so much for doing this. And then, as you're aware, we are working at 6LO on fragmentation, and Thomas presented the status of the design team to 6LO, and time permitting, he will show us where we are on that respect. So there's this strange thing at 6TISCH, which is that we are not like a usual working group just doing our own RFCs. A lot of our work is actually to aggregate, integrate RFCs from different working groups, find redundancy and say, okay, we'll work with this and not that, and find holes and missing pieces, in which case we go and push for some work in the working groups which are responsible for that. So examples of that are the work that we are doing at 6LO on the fragmentation. And then there is all this 6LO PanND update work, including the backbone router, which is part of our architecture. All this actually derives from work at 6TISCH. And we have the 6LO deadline time as well, which has a particular variation when the time is expressed as an absolute slot number in 6TISCH. Then we have all the work that we promoted at ROLL that includes the software-defined networking variation of RIPL, which is called DAO projection, and the unaware leave, which allows a device which is not aware of RIPL to get return routability through RIPL. And then the companion draft of the beacon that we'll be discussing later at ROLL is how you actually propagate and help on the DODAG selection. Very useful for 6TISCH, very useful for ROLL in general. How do you help select the right DODAG when you see multiple networks around you? And then we have say a relation or some common work with core, in particular the host core discussion for minimal security, for which we are working on this stateless proxy idea. And Thomas, with this, I will give you the ball, maybe? Just tell me to switch slide.
Yes, thank you. So a couple of things to add. So first, I'm very frustrated I cannot be there. My plane was canceled at the very last minute. I wish I could be there, but I think this works well. So another announcement we're looking at here at slide 02. So if you're looking on the link that Rahul said is the right one, we've been updating the slides with kind of recent work that happened. So if you have downloaded it yesterday night, you're outdated. So you should download 02. Before we get started with the drafts, 3 tiny announcements. The first one is that OpenWSN 1.14 was released a couple of weeks ago, and it implements the different drafts that we're talking about today. Next slide, please. There is a 6TISCH test suite now released 1.0.0 as part of FINTROP. FINTROP is this online tool that allows you to do conformance and interop tests online. And so there's a test suite that implements that covers the different drafts that we're talking about today on FINTROP, so you can test your implementation against it anytime you want. It's a free service. The next item, next slide please, is an announcement. I mean, it's a reporting that we had the second FINTROP 6TISCH interop event held a couple of weeks ago in Paris with the scope that you see here. Lots of fun. We ran whatever number of 88 different tests with a compliance of 97.1%. So that's good. It helped us tremendously testing this, and in particular, we tested RFC 8180, which has been tested already, but also the 6-stop protocol, and also the COGEEP part of the minimal security draft, and then 6LO RH. And that's it for me. The next, so let's get started with the agenda. Xavi, if you could come. Yeah.
Yeah. Hi everybody. Okay, I'm gonna present a little bit the status of this draft. We've been working on it since last IETF. We got the reviews from the ISG, and we answer all of them to the mailing list. On the right side of this slide, you see the different persons that send us comments, and this is the this is now the status of their claims or their questions. We published version 12 of the draft, consolidating all the answers we provide to the reviewers, and this was published the 20th of June. So this is mainly the status of this draft. So we are asking what's the next step, whether it should move on. And as Thomas already said, as a side note, we have this we have implementations, and we evaluated it during the last plaque test in Paris last 2 weeks ago.
So your question, Xavi, is whether we should move on with this, meaning it is now in the ISG hands, right? So we should wait for a decision.
Okay.
I think it's been published. Do you see any immediate action from the working group at this point?
No, I'm just asking whether we should do any action or just wait for the response.
What we can do, please, Pascal.
It is just out of your hands now. It's between the shepherd and the area director. And so basically, the only thing you could do was make sure that you have answered all the questions that were asked, and maybe chase the reviewers if they did not confirm that they were okay with your responses. But as soon as you got the okay and they're happy with what you said, the ball is no more in your hands.
Mm-hmm.
It's basically now for Suraj to ask for publication.
Okay, thank you.
Great work. Thank you so much.
Yeah, so Suresh not being in Montreal, we cannot ask him live, but we can, kind of keep track and then ping him
We'll follow on.
if it takes a little bit of time. Yeah, thank you.
And with this, we are inviting Simon Duquesnoy to the main stage.
Yes, so I'll give you an update on MSF.
Simon,
Yes.
t'as un gros écran.
Oh.
C'est bien que ça la vidéo peut te regarder.
Excellent.
Tu tombes bien.
Yes. So yeah, I'm going to give you an update of MSF, where the main action from the last that was decided at the last meeting was to merge ASF, which was the autonomous scheduling function, into MSF, the minimal scheduling function of 6TISCH, and this was done. So between version 1 and 2. So in a nutshell, MSF now, after the merge, has 3 types of cells. You have the basic minimal cell that comes from the 6TISCH minimal schedule. So it's one cell that repeats periodically, that's used for any broadcast. So it's a rendezvous cell. Everybody wakes up at the same time and channel offset. Then you have what we call autonomous cells, which are, it's one cell, every network maintains one cell, every node maintains one cell towards each of its neighbors. So you have one cell to receive, and you have one cell for each of your neighbors to transmit to them. And those are maintained autonomously. But then, the main limitation of them is that you have just one. It's just one per any pair of node. That's just one link to communicate. So on top of that, we have the dedicated cells, which were already present in MSF previous versions, which are negotiated with using 6P, with 6P add and delete commands. So whenever there is more traffic need, you can add more cells between child and parents. So I'm going to focus here on the changes since last time. So one of the major changes is the addition of section 3, which describes the autonomous cells, which put simply, so you have, as I was mentioning quickly earlier, so every node has one cell to receive. And the coordinates of the cells are derived as a hash of the MAC address of the own node. So I compute a hash on my own Mac, and from that I know which time and channel offset to listen at. But then for each of my neighbors, I'm also going to maintain a transmit cell so that I can talk to them. And I know the time and channel offset because I know the MAC address of the neighbor, so I can also compute the hash, and that's how this is done. Now the cells, they have either the TX or RX flag, and they always have the shared option because you might have multiple transmitter on a given coordinate. And one last thing worth mentioning here is that you have you may have collisions in your schedule. You may have multiple cells executing at the same point in time, and when that happens, we resolve collision at runtime exactly as defined in IEEE 15.4/2015, which is that transmit cells take precedence over receive cells, and we actually define a bit more specifically how we do that. So what we do is that you pick the cell that you have the most outgoing packets in your queue for, and then so that you can start flushing that queue, and only when all the TX cells don't have any any packet in transmit queue, then you can start considering listening on the slot. So that is for how the autonomous cells work. Now we have updated the behavior of the nodes at boot. So the way it looks now is that after you receive an EV, the next thing you do is to install the autonomous cells, so that you're straight away able to communicate on them. So you install your own RX slot and you install the TX slots towards your neighbors. And then you're going to be able to use these for the registration to your parent, so the join procedure, which was taking place before on the dedicated cells of MSF, which now are not installed at this stage yet. They will be installed at a later stage, only if there is more traffic needed between the child and the parent. So that is how the boot sequence now looks like. Now, one more thing is that, so when you have the autonomous cells, as mentioned before, it's just one cell for each pair of nodes. And if you have a need for more traffic, we have the 6P that's going to be used by MSF to install more cells between parents and child. But when we have short-term bursts of packets, we want to be able to handle them as well without having to install new slots, because if suddenly I get 10 packets to send to a given neighbor, I don't want to install more slots for just these. So instead, we use something that actually was already defined in 15.4/2015, TSCH, which is that you use one of the header bits called the frame pending bit to signal that you have more traffic to come. So whenever you start sending to your neighbor, you set that bit. That means there's more data to come. And then the next time offset. And the same frequency, not channel offset, but frequency. So you stick to the same physical frequency. Then at the next time slot, you send the next packet, and you can, as long as you keep setting that bit pending, that frame pending bit, you can keep on sending. And for the last packet in your queue, you unset the bit, and that tells the receiver that you can stop listening. So finally, we have, so we still have a number of issues left on MSF. All of them are quite minor, I would say, so I can review them briefly here. One is terminology. The cells, the unicast cells that are maintained by MSF between child and parents, they are called dedicated in the draft, but we think it's not the best word for that because dedicated means not shared, and the cells are shared. So we want to change that to installed or managed. We want to define clearer the list of packets that go to the minimal cell. We want to discuss a bit more about the length of slot frame 0, which is the minimal slot frame, and slot frame 1, which is the slot frame used for unicast. We want to separate transmit and RX counter so that when we manage the number of links or of cells that we need between a child and parents, we can manage separately the RX and the TX, and we can adapt to the load. We want to discuss a bit more 6P timeout for the backup mechanism that we have. And the last one is really a variable name change. So to summarize, or you want to ask a question now, Pascal, maybe?
Yes, Pascal Hubert.
Yeah.
So just a quick question about the Morbit, this thing that lets you continue, which is a great idea. If you don't get the hack, do you keep on insisting, or is there a, should
No,
there be
if
a
you don't
low?
get an hack, you stop.
So
you
it's
stop
written?
now. Yeah, and that's defined in IEEE 15.4 already, like this. So all we do here is that we point to the IEEE document and we mandate it. We say we need to use that mechanism, but we don't change anything to the virtual mechanism. So to summarize, we have integrated ASF into MSF. We have a number of issues, all of them quite minor, that will be fixed in the next version. And we wanted to discuss a possible call for adoption.
So let's maybe start by opening the mics for questions. Are there any questions? I don't see, but I don't hear any questions. So, Pascal, we in London we said that we couldn't adopt yet because MSF and ASF were not merged. But at the moment, can you hear me?
I mean, I don't see why we could not now. So,
Exactly. And so now that it's merged, I think we've already went through the adoption process. So I would, my opinion is that this has already been discussed and this should be adopted immediately.
yes,
Pascal, what's your?
we'll confirm. We'll confirm the call on the list and check that nobody opposed. We can have a short period just to validate. Like, let's give people a week or something. We have a good reason why it should not be adopted, because I have no expectation that anything will show up, so we don't have to give it a month. So let's just, on the mailing list after the meeting to do for us, confirm the call for adoption and give people a week. And next Wednesday, if nothing shows up, the document's adopted. You will need to publish it exactly like it is, just changing the number. So you may take the text file and change the date and the number to be sure you change nothing else. And that will be it.
And you change the name, of course.
The name, yeah.
So I'm shepherd of this, and the status is candidate for workgroup adoption in the data tracker. So pending confirmation on the mailing list, we'll just switch it over to workgroup document in a week.
And also, don't be surprised when you push the draft IETF blah. We'll get a mail. We'll have to push a button to allow you to publish. So it's going to take a little bit of time for us to wake up and push the button.
So can we write in the minutes an action item for the chairs? Thank you, Jacek.
Perfect. So
guess
just
that
in
is
time,
it.
perfect. Yeah. Thank you. And the next is Malisha. So Malisha, as I said, you have at least till 2:30 local time, plus a little bit of more time if you really wish. So.
All right, thank you. Can you confirm you hear me well?
Yes.
Okay, great. Yeah, so we published those 6. I mean, it's been, I think, like 2 months, sometime in May. This was mainly the input during IETF 101 in London, and then the 2 reviews that we received on the mailing list. One was from Xavi Villajozana, and the other one was from Pascal Hubert. In London, we discussed heavily the data structures and their extensibility. And this is the main change that we implemented in 06. Ever since we worked heavily on the running code, we have an open source implementation in OpenWSN of the constraint joint protocol, which is how we call the secure joint protocol now. During the 6TISCH plug test, as Thomas mentioned, that was held in Paris end of June, we tested this with an implementation from one SME that was based on a Contiki operating system, and we successfully achieved interoperability of the constraint joint protocol. Working group last call was on for couple of weeks in June, if I remember correctly, and there was a lot of activity about the draft. We received 7 reviews from the people listed here, and one of these reviews I completely neglected. It was from Klaus, that ended up in my spam folder. So I just saw it today, basically, but I updated the slides as fast as I could with these changes. So the goal of my presentation for today is to do a really quick summary of updates for since 05, and then to spend a good chunk of my time discussing the issues that have been opened during the working group last call. Okay, next one. Yeah, thanks. So the first change was related to the redefinition of CBOR structures. We had a couple of drafts published, mainly the Chavez draft on global time, that want to extend the structures that we use in minimal security. And the previous, in 05, we were quite rigid with the CBOR arrays as the top-level structs. So what we decided to do is to switch the arrays to maps, and then to add registries in the draft for registering basically CBOR parameters. And right now there are 2 registries, if I remember correctly. One for the labels of the top-level parameters that end up in this configuration object that is returned as the join response payload. And then another registry is actually for the values for one of these parameters. And as an example, now what we have, as an example of these parameters, we have like the link layer key set, we have the short address, JRC address, etc., etc. Another change that we did in terms of the CBOR structures was to optimize the inner objects. So while changing from arrays to maps introduced some overhead, in order to cancel this out, what we did is we optimized the inner structures, or these parameters that are passed as the maps. And with that, we defined, for example, one new structure that is called the link layer key that we use instead of the COSE key that was published in another draft. And the structure that we defined is much more optimal in terms of the message overhead, because we use just a sequence of elements and their type and their CBOR type in order to decode the element or the parameter, basically. So basically what you will typically have in your join response, you will have an array of these sequences, and based on the type, if it's an unsigned integer, you can tell that this is a key index that should be signaled in the 15.4 auxiliary security header, or if it's a byte string, you know that this is the key value. And then we have defined special semantics for processing these parameters in case of 802.15.4. Next slide.
You have someone on the mic. I don't know if you can see Tero, but Tero is on the mic.
Yes, I see. Yes.
Okay. Tero, one of the questions I have, because you have only key index here, and in 15.4 we can have different key ID modes where we can actually have this key index means that you have a global keys 254 in the whole network. There's also a way of having this kind of keys that are not owned by the controller but owned by somebody else. If you have a multicast group or something like that, which then requires to have either PAN ID plus the source address or the extended address of the owner of the key. Do we have any plans of actually supporting those? And if so, do we actually want to, specify how they are transmitted here, in case we actually at some point, especially if you think about, we don't have if the coordinator and the the JRC are separated, it might actually be have keys that are actually owned by the JRCs different than you might actually have a broadcast keys that are used other one, and they are not necessarily coordinated together in the same address pool.
Okay, so if I understand correctly your question, you are asking if we want to support the pairwise keying and other modes other than key index. Is that correct?
Pairwise keys, actually pairwise keys is one other thing, yes. But I mean, this is the other type of, because I mean, in 254, keys you have there is global to the whole network. But then you can actually have, this kind of longer identifiers for the key, meaning the owner plus the key index. And the owner is, either 4 or 8 bytes of, the owner identification.
Yeah,
clarification, so, they are not used during the minimal flow, right? Those are keys that would be used later.
No, they are something that they used later, but I understand this is also for rekeying, and actually this most likely the same structure is going to be used for all kind of keying. So that's why I was thinking about, should we think about here how to extend this, even if we say now that we always use key index and on the global keys, but in the future, especially with the CBOR stuff, to make sure that we actually, can make, so we don't end up, oh, suddenly we have this, we can't put, for example, this 8 bytes of owner information there because people would assume it's a key, because the key is the binary string. So we have to put, this is the things that we have to think about here.
Yeah, no, I mean, just to be clear, I mean, this is something that I already considered when I was defining this link layer key structure. And my intention was at first to mimic the data structures that you have defined in 802.15.4 in order to allow full support for any kind of keying that is enabled in 15.4. But then the message overhead was huge. And I decided that for the link layer key, we should just stick for the key index. Maybe it would be better to, maybe then we could rename it to be more appropriate, that it reflects that this kind of object is only for the index mode. And we could define other other structures that would carry the parameters needed to set those kind of keys if there is interest in the working group.
Yeah, actually, I was thinking about one of the ways to do that actually was to say that after the key value, because that's always there. So now that there's one binary string, but after that you could have a key owner, which would either be it would be string that will either be 4 octets or 8 octets, depending if it's the key ID mode 1 or 2. The one that if they are missing, you are using key ID mode 0. So that will actually be it wouldn't make this, if I understand correctly, CBOR, it's not, if the optional fields after, the last field aren't there, the structure isn't getting any larger. It just changes.
I see. Okay, so you're saying basically that even though the field is a byte string, that based on the length of the byte string, we can say this field can be decoded.
Yes, yes.
Okay, I see. Okay, so for what I considered mostly was the type of the field with and then with byte string, if you have 2 consecutive byte strings, you don't know which one is which if the one starts. But I mean, let me get back to you on that. I'm not sure if we want to do that right now for minimal security. This would be the fully blown support for all the security features, since this is kind of like the idea of this is minimal, and with the changes to have the top level structure as maps, I mean, this can easily be extended in another RFC. So I'm looking here mostly for the input from others if there is interest in supporting other keying modes than index.
Let's keep that for the mailing list because it's a minor issue compared to the others. And
okay, yeah.
It's not actually needed for this work anyway, so it could be actually trouble if you define something that you don't choose. People later in the review process will say, hey, why do you define this? People may use it and then you don't need it. So I'd rather, have the RFC which needs it, extend this one for putting this option that you declared.
Yeah. So I mean, just to conclude, my personal feeling for this is I'm okay to add a new data structure, but not to mix it within this one that is already there and that is very optimal and that corresponds to the most frequently used setting. Yeah, but let's continue that on the mailing list. Can I have the next slide? Yeah, thanks. Yeah, so the second major change was that we homogenized the protocol to support the joining of the 6LBR or the coordinator. And basically, I went through the trouble of checking in the document what text applies equally to the node, to the pledge that is joining as a non-6LBR node and to the 6LBR pledge. And there are some changes. Also, we added one parameter that is the role parameter that is sent in the join request that differentiates basically. And with all this, what we do is that we enable the same protocol to be used to bootstrap the 6LBR. Now, the parameters that the 6LBR pledge gets in response are different, of course, from those that a non-6LBR pledge gets. And there was some discussion on the mailing list. Changes were not heavy, but there were some changes, and especially in the terminology part, where I had to differentiate between pledge that only means non-6LBR pledge, 6LBR, etc., etc. Yeah. Next slide.
So, Malisha, clarifying question.
Yes.
About previous slide, yeah, change 2. So except for the editorial changes, the only thing that that changes is the contents of the join response, right? You just have different. The JRC gives it different values. How does the
So in
JRC
the
know?
join-
Please.
Yeah.
How does
so in
the
the join
JRC
request,
know? Yeah, great. That you're answering my question
in
already.
the join request, can you hear me?
Yep.
Yeah, in the join request, basically there is a parameter called the role that if it is not set, if it's not present, means non-6LBR, just a regular pledge. If it is set, it's the 6LBR. And then there is a sentence just saying that this communication happens over another network interface, just not 15.4, but it's the same protocol. It's the same, that is used on any other pledges. So you see the join request here, you have the role. If the role is not present, the value of non-6LBR is assumed, meaning just regular pledge joins. And then if 6LBR tries to join, it sets it to 1.
Thank you.
Yeah. Okay. And then the third major change is on rekeying. And basically, we added here a mechanism that was discussed heavily after IETF 101 in order to allow the JRC to update any of the parameters during network lifetime. And with this mechanism, basically, we also implement rekeying. So let me explain briefly how it works. Pledge, once the pledge completes the join process, during the join process, the pledge acted as a co-op client. Once it gets the keys and successfully joins, it switches the co-op role and becomes a co-op server and exposes the /j resource. Now, JRC is aware of the IPv6 address of the node implicitly because it knows the network prefix and the network short address and the extended address, so it can construct it. And it is able to reach out to any of the network nodes to send a co-op message. So now this co-op message is completely a different co-op message from the one that was using in terms of joining, when pledge was joining, in terms that it does not contain same options and it's just pure co-op. It's confirmable. There are less security issues compared to those with joining. And what JRC basically does, it just sends a post request where it encapsulates in the payload the configuration object, configuration CBOR object with the parameters. And now for every parameter, there is semantics on how it should be handled when received as part of this update, parameter update request message. With this mechanism, we allow JRC to reach out asynchronously to any node in the network and to update the parameters. And with that, we implement rekeying. For example, we implement that just by specifying the rules of that the node follows when it receives a link layer key object, for example, as part of this parameter update request. And there is a differentiation between regular network nodes and the 6LBR to implement the rekeying. And what happens is that basically 6LBR will install the new key immediately once it receives it and starts using it. All the other nodes will install the key, but they will wait before using it for outgoing traffic until they see encrypted or protected frames that pass the layer 2 security verifications with the new key. At that moment, when they see traffic encrypted with the new key, they just switch and start using the new key for all outgoing traffic. Now, there was a comment by Tero on this, so I'll get back to that later. And the same mechanism here is used to update the short addresses or basically any other parameter.
So one quick question about this. In London, we had as an action item for you to evaluate the use of fetch. You went for a different co-op message instead of fetch. Yes. Is that correct?
Yes, okay. That's correct. I mean, we used fetch in order. So basically, we first attempted to do this as an observation of the join resource at the JRC. Mm-hmm. So basically, that we would include the observe option in the request, in the join request. Mm-hmm. This was the first attempt. But then since the join request was the post, we cannot observe a post, and that's where fetch came in. But then there were problems in observing from an endpoint that has a different IPv6 address, because pledge used a link local IPv6 address for joining that goes over proxy. When it becomes a network node, it just goes straight to the JRC. So then there were difficulties in the co-op, in being compliant with co-op and doing this. So finally, what we resorted is just that the pledge exposes /J once it joins, and then JRC does a post, a simple post on this resource.
Thank you.
Yeah. And then the fourth change is just editorial. I mean, we aligned, there were many editorial edits and clarifications. We aligned the key derivation with OSCORE 13, registries, etc., etc. And then we rebranded the joint protocol as Constrained Joint Protocol with abbreviation COJIP. Yeah, so with that, I will switch to the working group last comments. I don't know how much time I have, Pascal.
Clarifying, you have 20 to 25 minutes. Clarifying question about OSCORE. Last time we talked, you depended on the change that was to come on OSCORE. So I understand that that change is OSCORE 13, and now we are aligned, right?
Yes, we are aligned. And the text in 06 is it's aligned. It's aligned. It can be clarified even better, which I will do as part of the working group last call. But I mean, there is no major. I mean, 06 can be implemented with 13 without any problems.
So you have 20 to 25 minutes.
Okay, yeah. So we had, as I said, we had 7 reviews as part of the working group last call. One of the major ones is what to do with the stateless proxy option. So just to sum up, we want to remove any state from the JP and enable it to act truly statelessly when forwarding the messages during the joint protocol. And this is important in terms of the denial of service protection, because traffic from pledges is, of course, unauthenticated. And if some state is kept at a joint proxy, then just an attacker can flood it and prevent other pledges from regular pledges from joining. But the semantic, this is a new co-op option that we define in minimal security, and its processing is quite similar to the co-op token. Co-op token from the base RFC 7252, but the problem is that the value that we need to put in the option does not fit in the 8-byte co-op token that is defined by 7252. So then there were 2 questions, one raised by Joran Selander about whether we can use the token instead of this new instead of stateless proxy, which is possible in some cases, but not in all. And then the second comment was from Klaus, who raised a point about duplicating features in co-op with this option, since we are defining a new co-op option that can be used for the general purpose co-op. And also he raised the point that this option may not always be echoed back in some cases where there are errors or when the intermediate proxies do not implement it. So just to brief the working group on this, we are working together with core experts on this issue, and we had a meeting this afternoon on trying to find the best way to proceed. And the attempt here is to find something that is both that works both for general purpose co-op and for our use case in 6TISCH in minimal security. So I mean, I will keep the working group posted. We have some side meetings on this, and also I will present our use case during the core meeting tomorrow evening. Yeah. So the second issue was raised by Tero on the decision that is important for the JP. So let me sum this up. JP needs to accept frames that are not secured at link layer for the duration of the joint process. But now the duration of the joint process is vague. And we had a couple of discussions on this. How do we pass the information that the JP should enable the joint process and that it should accept unprotected layer 2 frames? This was discussed heavily during IETF 99 in Prague, where we explored different options. One of them was just to abuse the join metric that is present in the EBs, and basically to use one value of the join metric to signal that join is not allowed. And when, for example, a join proxy would see this 0 hex FF for example, in the enhanced beacon of its preferred RIPL parent, it would not accept any unprotected layer 2 frames, and therefore not accept any new pledges into the network. Michael was active on this. Also, Pascal had a couple of comments, and as a result of the discussion, Michael published a draft that is extending significantly the join metric and adding lots of different semantics on it in order to add more, to enable more complex features like proxy giving priority. The priorities between proxies depending on traffic loads, etc., etc. So this hasn't been adopted yet. I think Michael has a presentation afterwards, or whoever is filling in for Michael. And this is one part that we are currently missing, as Tero said. So I propose here 3 options that how we can proceed. We can keep working on this as part of Michael's draft. We can include a simple solution in minimal security where we abuse van value of the join metric to signal join is not allowed. And this would, in case, for example, it comes from the RIPL parent. So it would propagate similarly to how we propagate time in 6TiSCH. And then basically what it could enable is a button press on the coordinator, physical button press, would switch the join process on, first on the coordinator, and then this information will propagate down the mesh towards all the JPs, and the new pledges would, the frames of new pledges that are not protected at layer 2 would be accepted. And then the third option would be to do this at the COGIP layer in co-op, to define, for example, a COGIP parameter that would be sent as the parameter update in the parameter update request message that would say to the JP, start acting as the JP, or an update and allow these kind of frames. And we could add the semantics there, for example, how much time, etc., etc. So, I mean, I'm really looking for input from others on this, on the best way to go ahead.
This document, I actually think you actually a little bit misunderstood what I actually was asking in the original.
Okay.
Originally, you know, thing was more or less how the JP knows if there is, you know, one of these peers is actually, you know, when it starts doing, you know, this joining process, the joining node, connects to the JP and then does something. And I was assuming because the JPs, usually they store, even if you say it's completely stateless, you can actually, I didn't really understand if you can actually make it completely stateless. And so actually I was assuming that it has some kind of state and it needs, like we were talking about secure neighbor cache and so on, it needs to know when it can actually remove that state, when it needs to stop allowing that node to be sending it unencrypted payloads. And at that, because that configuration is per node, he doesn't need to know if the whole network is, you know, whole network might still be, you know, allowing, you know, joins, but he doesn't want to, you know, that one node to do that anymore because it's already done, because he just doesn't want to keep opening, you know, keep the, you know, hole open for somebody to attack him by sending, you know, faking to be the node that joined a couple of minutes earlier and sending clear text packets. So that's why I was thinking about, you know, it's of course now it's very easy, you know, set one frame and one frame comes back, but in the future it might be something that we actually have a multiple round trips going back, and I think it's actually a bad idea to have a JP, you know, not knowing when it's usually easier if the JP knows when the process is finished, and also he needs to know if it was successfully done or if it failed. Because if it failed, he probably wants to blacklist the node. Because what happens there, if you have a wrong key or something like that in the chaining node, he joins, tries to join, goes to the JRC, JRC says wrong key, it goes back, he gets wrong key, okay, I will wait for 10 seconds and try again. And then he tries again, consuming resources. And then when everything is done, he says, oh, I wait there for 30 seconds, come back again. And then he's doing that for a couple of months until somebody actually noticed that, oh, we have this node there that has actually been trying to join because we didn't actually configure it in the JRC ever. So that's why I was thinking about, okay, the joining JP might actually want to blacklist that node and say, okay, yes, even if you try to join to me, I'm not answering to you because go away, do something else. I don't want to hear about you.
But
And this is the thing. He needs to know if that's actually, if it was failing or succeeding, he can actually do this kind of blacklisting and that kind of things.
that can be done totally internally, right? I mean, is there a way to signal anything or specify anything? I don't see that we have a need to specify anything for doing that, because the JP is on the way. If he wants to keep a blacklist, he can keep a blacklist. I mean, it's completely optional on its decision. We don't have to mandate that.
Yeah, but if we ever, for example, make it so that, okay, we might have the joining process might be actually a two-step process. You first authenticate something, and then you JRC says, okay, here is your first stuff. Then you do the second step or something like that, like next pin type of thing, authentication. If JRC pulls in the first, after the first, okay, this is the first exchange done. Okay, he's trying again. I will blacklist him. We can't actually do this kind of extensions.
Yes, but do you need anything in the spec to do that, or can that?
What I was thinking about, it would be useful to have in the response coming back from the JRC to have something for the JP to say that, okay, yes, this process is now done when you have provided this process, this packet to the, to the joining node, and it was done successfully, or no, it was failed, or there is lots of stuff going on.
I don't see, I mean, the part where we disagree is how is this information relevant to JP? I mean, semantically, this is not JP's decision. You can, typically, if you have a 50-node network, 50 nodes can play the role of the JP. And now you're saying that each of these 50 nodes will be doing an authorization decisions, who should be joining and who should be blacklisted. To me, this is a centralized decision for the JRC. And if it's a centralized decision, it should be the JRC who decides, okay, I'm getting too many packets from this pledge. This means something is wrong. Let's blacklist it. And in my email, I gave a proposal how we can implement this. But the main part where we disagree is on, I don't see this as a decision for JP. This has nothing to do for me with the JP.
I agree that it could be done without, but I have noticed that in some places it actually is easier if we actually know what even if just proxying things. For example, in IC version 2, we are proxying EAP exchange. And one of the things we actually need to know when the process is either successful or failed, so we can actually know, okay, it was successful, now I need to do some other magic tricks there behind the scenes to be able to do some other things. And that kind of things, even if you're just proxying, the authentication information through, we still might need to have it's useful to have a clue of what's going on there. How many?
But I don't see how it's useful. Yes, I'm missing the part. Yeah.
It might be different here, but I was just think about this, something that I wanted to ask if it actually would be useful to have this. But I think you are feeling that there is no need for JPEG to know anything about the.
At the moment, I don't see, because I mean, when the pledge joins, I mean, it may never ever communicate with this JP again. I mean, this is the key point. I mean, this was one node that was selected based on the information in Hans beacons. From the moment the pledge joins, it can decrypt DIOs, it selects its Ripple parent according to the Ripple specs. It may never again communicate to the JP. And to JP, there is just, I mean, I don't see why should this all be relevant? But I mean, we diverged a little bit from my slide here, because the issue that I think you raised here was how does JP know whether it should accept the unprotected frames at layer 2? And this is a valid concern. So yes.
Yeah. So I think it's a twist on what Tero was talking about, but it's essentially the same thing, right? It is switching on and off the capability for nodes to join at the JP level, whether it's a decision made by the JRC or not. My question is this mechanism or is this policy? I mean, if I wanted to implement this kind of behavior, I have all the tools at my disposal to do this in an implementation. You do not?
At the moment, no. At the moment, no. I mean, I mean, you have the join metric. You would have to abuse one value of the join metric for this. And this is one resolution that I was proposing earlier, is basically to say 0hex FF in Hans beacons for the join metric means I don't accept any pledges. everything else is according to 8180. But then we said we wanted this to be more complex to allow different use cases, and this is Michael's draft.
Which is very thin. I mean, something we could progress quite rapidly, because most of the work which relates to Michael's draft is actually the work at raw. But here we just need to present the interface in the beacon to say, basically signal we want to join or not, or join preference. And that's it. I mean, we can, and then we can publish that document very quickly, so we don't delay minimal. The point, Manisha, is that option 1 and option 3 are not equivalent.
No, I know. These are different paths. Yeah.
Mentioning
option 1 and option 2 for me are quite similar.
Yeah.
I mean, it's in the enhanced beacons. This is, but you would still need some. If the JRC is in the cloud, you would need to trigger this somehow. If it's the JRC that decides when the join should be enabled.
Yes, that's what my point.
Even though
you can do one, for instance, and still in the future create an improvement or an addition to minimal that does 3, because it's really a different protocol or something that you can always define later. We can move minimal the way it is today without that, and always define it later. It's kind of a global toggle. My network is stable. I don't want to do any join, and that's a global decision by an external entity. The enrollment beacon is more like this network is more loaded than this one, so in terms of balancing, you'd better join here. And actually, this proxy is doing a number of flows already. It can hardly take more. This one has more resources. Just use the other one as join. Right? It's what the enrollment and beacon does. So it has to do with basically a notion of local load, not policy or administrative decision of taking or not taking new joins.
Okay. Yeah, I see. So these are two different metrics then. Yeah.
We need the two, and we mostly need to move. Either we decide to move the draft of Michael very quickly, or we go for option 2, which would be sad. But I think the idea is to move draft Richardson very quickly.
Okay, and what do you feel about option 3, where JRC reaches out to every node? Too much overhead, or
different draft that you can do later? It's just
okay, but this would be just a single. Okay, yeah.
Yeah. So let me reinforce this. I think we're very, very, very close to having this ready. This is. It seems to me like this is another feature, another capability. It does not. It's not like the draft is broken. It's that this could enhance the draft in some way. So I would say this could be a different document. That I wouldn't want to stop the progress of minimum or stop kind of the. We're in workgroup last call, right? So if we decide to work on this, we have to go back to the working group and go and do another workgroup last call. Whereas I think we're there yet. We can push this and then have. If this seems interesting, we can have an extension, and everything that you're describing are all extensions. It doesn't have to be part of today's document. That's my
right. As it goes, the enrollment beacon can describe that piece by itself for what it does, and as part of the option 3. Option 3 is part of your manageability. So if you want to do anything in this draft about option 3, the only thing you can do is have a manageability section where you say which kind of objects in minimal can be managed from the outside, and just say, okay, there is this bit, which means on or off, that can be managed from the outside, and the protocol to manage that bit will be just like the protocol to manage hundreds of things in the object.
Yes, but I think we can implement option 3. This is one paragraph.
Yeah, it can be just that okay, you manage this bit, and it will be managed like with whatever object management we're going to use, right? Komai or.
Okay.
The particular protocol to the bit, right? Just to manage them.
Okay, all right. So we continue this on the mailing list, I suppose.
Yep.
Yes, please. But let's get this shipped, right?
Okay.
You have 5 more minutes, and you have 7 more items. So
yeah, there's no way I can get it. Yeah. So this is the. So let me just think. I think this is the point raised by Tero about layer 2 state. So let me just sum it up briefly. Basically, Terra raises a point that with the compliant 802.15.4 security implementation, JP needs to keep some state. I responded to this email just today. I don't know if Terra, you had time to see it. I think there is a mechanism that this could be implemented fully compliant with 15.4, the one that I sent in the email today. But I also would like to note that there are many existing implementations where this performance hit that you describe simply can be bypassed, because it is possible to add something in the MAC layer where you could signal, where you could pass this frame upwards, even though it's not super compliant with 15.4 APIs. Next. Yes, so another issue by Tero, I think we agree on this. He just proposes to add a simple delay, a configurable delay, when a node in the network receives the new key before removing the old key, in order to account for possible losses and that some nodes might receive the key before others. So yeah, I think we agree on this. I mean, we can implement this in the next version. 5. Yes, Chavi raised a point about the error handling at the COGEP level. Basically, this is the semantical handling of the errors of the parameters passed as part of COGEP. I mostly agree. I agree definitely with this. We focused so far on the errors on the OSCORE level, where we try to protect from denial of service, and there we had a couple of exchanges, and the main conclusion of that part was basically we don't send any errors that are related to OSCORE processing, because they can just open the denial of service vectors. Handling. Yes, so Travi raised the point about how should the JRC handle if the node in the network cannot be reached. For example, if it tries to rekey it, we agreed on the mailing list that this is an implementation decision, but that we should explicit it so the implementers are aware of it. Next, please. Yes, so this issue was raised by Jim Schad. This is an important one about nonce reuse. Basically, right now in the draft, we have we mandate that all the OSCORE security parameters are written to persistent memory, both at JRC and at the pledge. And this is an important security requirement. Now, what Jim raises is that if JRC for some reason dies and all of this information is lost, what happens? JRC dies, JRC is in the cloud, it dies, 6LBR continues to operate. So the network is operational. Now the same company brings a new JRC. How does it continue? It doesn't know the state, the security state with the nodes, and if it tries to use the keys that it has from some database, it will reuse the partial IV. And therefore nonce reuse will occur, and the confidentiality, authenticity, basically all security will be lost for those frames. So now the question for the group is, how do we handle this? We can. There are a couple of cases here, and I don't think we have time now, but maybe the best is to continue the discussion on the list. Is it enough to mandate that all of these parameters are written? This is already mandated, but basically to I didn't think this through. Yeah, so let me get back to this on the mailing list. I have doubts here. Should this case be accounted for? This means JRC going down, all the parameters lost. Can we mandate that with some out-of-band mechanism, the coordinator needs to force all the nodes to rejoin?
Manisha, we have a mic here.
Jim Schad. Last night I came up with a way I believe this can be solved by forcing one additional round trip the first time JRC2 tries to do a parameter update. I'll get it out to the list in the next couple of days.
Perfect.
Okay. Thanks, Jim.
Thank you, Jim.
This issue was raised by Teng Fei, basically with the updates where the COGEP supports the joining of the 6LBR. we enabled the 6LBR to be bootstrapped. And we were missing a couple of parameters that are needed by the network and that the JRC can configure into the network, such as the time slot template, channel hopping template, etc., etc. And with this, I think we have all the parameters needed to have a fully autonomous JRC in the cloud and managing multiple networks and updating the keys, etc., etc. Are there any objections to this, or?
Thomas?
Yeah, so no Chair Hatton. So this is the beginning of an infinite list of feature requests for adding this and that parameter. Mm-hmm. My personal opinion is that, you know, let's have something minimal working. If this is, you know, really an issue, then somebody can write a different draft. What this is talking about is I have a 6. It's a very, very specific use case, right? I have a 6 LBR that joins somehow a JRC, and the JRC needs to configure the 6 LBR, and configuration can be all the way to like what's the color on the box. You know, there's so many things that can be configured. If we start creating a list and maintaining IANA register, you know, it will never stop. So my personal opinion is that let's not enter you know all of these configurations, because in 15.4e and 15.4e there's many more than these things that we can change, right? What about this? What about that? So my personal opinion is let's not go there.
And with
Okay,
Thomas,
so you're saying
we have a long history of overloading AAA mechanism with configuration and using them or misusing them as configuration tools. Let's build a young model of our 6LBR and let's use a COMI or something to configure the 6LBR. What we want from the join process is the 6LBR to be identified as a 6LBR and to be able to securely connect. Once we do that, then we can use, I mean, a YARN that we can always extend to go and configure these things and all the rest.
Okay, I see your point. Okay.
Very good reason why it belongs there. And I understand for things like the short address, but if you start generalizing it to anything, no.
All right. Yes, then there was an extensive review by William on the Bitbucket page. I responded, I mean, we have a couple of optimizations that we can do. I mean, this is not major. I mean, I will discuss this with OSCOR authors if some of these can happen. Second optimization, okay, can I just go back? I mean, 1 second. Yeah, it was regarding the short address lease time. Currently, this lease time is encoded in seconds from the instant the COGIP message was received at basically at the pledge. Can we round this to minutes, hours, or days maybe? Is there any objection to this?
I mean, these are very long-lived networks. I mean, it takes hours to bring them up sometimes, so having a life second looks like silly.
Yeah, so I mean, this would just prevent all saying like 7 hours and 15 minutes and 3 seconds. So we would just be limited to like 7 days. Yes?
What are we trying to solve here? What's the problem?
So it's the lease time. Tero brought this point up. He wanted to add the lease time to the short address assignment. It's an optional parameter. If it's not present, it means infinite lifetime. Yeah. If it's present,
what's the problem with seconds?
Just the overhead, because it's a large number.
Okay.
And then the final one, but this goes along the adding features. This is William, who requested if there is interest in the group to support fragmentation by co-op blockwise. And for now, we implicitly assume the fragmentation being done at the 6th open layer when it occurs. In the default cases, we ensure that the fragmentation does not happen. But when it occurs with fully blown object, we assume the 6th open layer. Now he was asking about using blockwise, and this would indeed enable the protocol to be used in non-IP networks, but I don't know if there is interest for this.
Okay, Manisha, unless there is a question, we need to stop there, I guess.
Yeah, sorry, okay.
So no question in the room? well, we've got work items. There is nothing really blocking. I really hope that your co-op meeting goes well, and please let us know as soon as it's done how it went. And with this, many thanks, Maisha. So Michael cannot be with us. I built a number of slides on his behalf, and since we gave the time to Manisha, we'll skim them through them very rapidly. So the biggest news for the zero touch is that Anima now is well advanced. Ruski has gone through workgroup last call, and the constraint voucher on which we depend for this work has been adopted. And Michael's hope is that it will workgroup last call this year. So yes, zero touch security 02 was published. Co-authors gone, so maybe Michael is looking for a new co-author. And the main and important thing to see is that this document is completely aligned with the Anima document. It's just when you do this in Anima using, I don't know, HTTP, here is how you're going to do the same thing with us. Here is how you will format this. Here's the protocol that will match this other protocol, etc. Everything is matched one-to-one. That's pretty much what this document does. It does not really reinvent the world. It really maps the methods to our world. And basically, you will find this explanation of the different pieces of protocol which are done by which document. The MASA is where is the vendor with its where the original authentication lies. And more urgent for us is the work on enhanced beacon. So we just said we've got this dependency on minimal security so that we can actually expose joint preference, an extended notion of joint preference on the beacons, so that when you've got this node coming in and trying to find a joint proxy, it will hopefully find the right network in the middle of possible networks. And then inside that right network, it would find a proxy which is not too busy, which hopefully is not too far from the root, etc. So it will figure out which is the best possible joint proxy for it. It's not meant as an administrative method for preventing joins, but it could be used that way by just having every joint proxy not announce themselves or announce that they're fully busy. Won't go back through that because we don't have time. So the document has changed a little bit to extend the capabilities of the option as it was presented last time. So here is what it looks like now. Yes, we can go through the slides. We don't have time now. So if you're interested, please go through the site that I built. So for 6TISCH, the only thing we have to do is really expose this little, agree on the field, but there is no rocket science in there. Agree on the field, put that in the beacon set. So it's really something that we can do very rapidly. The point being that we will have a normative reference on it in minimal. So that really means that minimal will not get the RFC number until this thing gets its RFC number. So if we accept to depend on it, based on Manisha's proposal earlier, then we really need to progress the damn thing and go through with it. It was called for adoption mid-June, so the call is passed. I've not seen anybody objecting. So in the interest of progressing, the document is adopted. And I'll confirm that on the list. And so we'll ask Michael to publish a 00, blah, 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 as usual. Question, discussion? Chabi, ball is yours.
Okay, do you hear me well?
Yes.
Okay. This is a status update of the global time draft. This draft was published in the previous IETF, before the previous IETF, and presented there. This is not a non-charter item, but we think it's an extension or a relevant feature that would bring some new applications or some new advantages to these networks. We published this update following the mailing list comments we received, and we produced the version 1, and also adjusted the format of the options that we define in this draft to the CodeJIP format that Malaysia already presented.
Chavi, is there a dependency on this in minimal, or is it just completely orthogonal?
It's it's dependent, I guess, because we discussed in the previous meeting that if we want to use this through the constraint join protocol, we need that the GRC is also the global time manager, or the global time node in the network that is able to do this mapping between ASN and global time. And if we want this to work from the beginning when the node joins, then it has this dependency that you have to transport these options as part of the constraint join protocol. Yeah. So I followed the comments on the mailing list, and I removed some of the options we had, mainly because they had security issues. Basically, we were enabling to have this global time service as an external thing out of the GRC, and indicating what is the address and the service that is exposed. But these had other security problems like redirection, or that the node is not authenticated by this new service, so that would require some new keys. And I removed that part, so the interaction is now from the node, from the 6N node through the global time service that is exposed by the GRC. I updated the data. I don't know if I have more slides. Maybe you can to the next. No, go to the previous one then. Yeah. So no, the next one. Yeah, that one. So the main issue is that now the interaction has changed. Before, when a node had this global time option installed, it had a lease time, and it was asking to the GRC to get an update when the lease time expires. But now the interaction model through the parameter updates that Militia exposed are in the other way. So my guess is that I need to switch that now and make that the GRC updates the global time to the nodes when the lease expires. So that's one of the things I need to do in the next version. But another more critical thing that I want to discuss, not today, but in the following 6TISCH meetings, is how we ensure that the GRC can know the mapping between the ASN and the global time. And I can understand that the GRC can have this global time through NTP or through any external protocol that brings to it global time, but the GRC needs to know as well the ASN of the network. And this is something that we need to make sure it's doable and possible. And that's it.
Is there any question on this? Let's continue on the mailing list. This is very interesting work, but we don't have time. And Jonathan, I will ask you to be very, very quick because there is yet
okay. Okay, can you hear me well?
Perfect.
Okay. Well, this is a draft about all the considerations future implementers will have to take into account when considering implementing 6TISCH over more than one physical layer. No? So, well, this is the table of content of the draft. So this is the considerations. They cover pretty much all the 6TISCH protocol stack. Next, please. So, well, 6TISCH protocol stack only defines from the link layer up to the application layer, but is the de facto physical layer, the one of 15.4/2006, OKPSK 250 kilobits per second, 127 bytes. But then new amendments at the 15.4G includes more physical layers with different characteristics and different capabilities, such and with variable data rates from 6.25 kilobits per second up to 800 kilobits per second, and a frame length of 2047 bytes. Also, there are new radio chips, such as OpenMode B from OpenMode, that they can implement both 15.4 and 15.4G, and for sub-gigahertz and 2.4 gigahertz. So this makes possible to have a 6TISCH network where nodes will have or can have multiple physical layers at the same time, and so links can happen in dual bands and can happen over different physical layers. So one of the first considerations to take into account will be the definition of neighbors. So here, for example, we see that nodes A, B, and C, when using physical layer A, node A is neighbor to B, B neighbors A and C only neighbors B. Next, please. When then consider another physical layer, they might implement everybody neighbors everybody. So then, next, please. Then now, what happens when these nodes can implement in the same network more than one physical layer? So the definition of neighbors changes to any node which is within the same interference domain, but for a given precise physical layer. So this changes how neighbors store their or manage their nodes manage their neighbors information. So going to the max layer, the considerations is at the moment of the network formation, for example, nodes that in the current 6 applications, they have to listen for EVs. So, well, we know that nodes will listen in a round-robin fashion for 1 EV over one of the 16 frequencies. But now this list or this amount of frequencies nodes can listen to will multiply or will expand if we include multiple physical layers and with multiple frequencies, no? So this might be very heavily in terms of energy. So here, future implementers, they'll have to come up with a mechanism to improve the joining process and to shorten this time.
Jonathan, I will ask you to hurry.
Okay. One of the things about as well is about the time slot durations, because here, since we have such a variable data rates from 6.25 kilos per second up to 8,000, if we favor slow data rates, then when we're using faster data rates, all the time slot will be lost, no? So we will decrease the amount of, well, let's say the efficiency of the network. So also, since we have different physical layers having different characteristics, also for the channel hopping sequences, we cannot identify them just by a numbers, because for different physical layers might mean different things. Also for resource allocation in the 6 TOPS layer is that resources are measured in amount of cells, but when having multiple physical layers, cells don't mean anything, because for a specific time slot duration for low data rates, you can pass less information than when having higher data rates. Also, here we think in the 6 TOPS layer, we miss a kind of mechanism how to cope with regional regulatory norms or legislation, because if we use sub-gigahertz frequency bands, these are very highly regulated. So there must be a mechanism that takes into account this regulation. Next, please. Well, this is my last slide. Also for 6-low-band considerations, now that, since it was defined with 15.4 occupancy gain in mind, now we have having multiple physical layers and capable of sending more than 137 bytes per frame. So 6-low-band should adapt to send more bytes per frame, no, when doing the fragmentation. And also, well, to end this presentation, about the ripple considerations is here we foreseen that new objective functions should be written or taking into account the resource occupancies or the throughput and energy consumption of the multiple physical layers.
There is something in 6552 about that.
Yeah, about the rank, what is called the rank metric. Yeah.
The rank factor. You can
the rank factor.
Different rank factor for different files.
Exactly. So, yeah.
Thank you, Jonathan. And our last presenter today will be Yatch. So Thomas, I'm sorry, but I guess we don't have time for the fragmentation. We gave an update at 6 low, so I expect some people in this room were already at 6 low. So that
No problem.
we're for today. Is it okay?
Absolutely, no problem.
Yasik Tanaka. Hello. My presentation should be quicker. So what happened is that I was struggling to understand the retransmission algorithm defining the 15.4 standards. So I asked for help on the mailing list, and then this slide captures my current understandings. So if you are interested in the algorithm itself, or when you're implementing this algorithm, please take a look at this slide, which could be helpful. So, and also the TELs told me that now the IEEE 15.4 MD, that's the group, now working on the revising the standard text. That's so we would have the clear and revise the text and the figures of the algorithm in the future release. That's maybe release in a couple years. Taro, do you have any estimation? Taro? No? It could be done this year. So the revising the standard document.
Oh, the revise of the standard documents, that is the document. They're starting working on it now. They have lateral ballots starting between this meeting or just last week and September. And then I think the plan is to have it out when 2020, because they say the 15 for 2020 sounds cool. So it's going to take a couple of time, but of course the text is going to be stable, or should be in letter ballots and so on by the end of this year or so.
Thank you.
So Tero, I have a question for you actually. What is the right way for so Yach found some things that are not very clear and try to clarify them. Is there are you the right person to convey those messages? Is there an inbox where you can drop these things, or what do you recommend as feedback, or will you serve as liaison?
So there should have been a formal liaison request coming to IETF saying that, okay, this is the current version of the draft which we are going to be editing. Do you have any comments? It probably has been disappeared somewhere in the IETF, administrative or something like that. So I don't actually know what would be the formal process of doing, but I will be in the IEEE meetings. I will be actually doing it and I can put in the comments. If you have any comments that you found out there, if they send it to me, I can put them in as a comment for myself, and they will be then acted on. And then there's if there is there is the IEEE has a mailing list that I think you can actually join that, but it doesn't. But most of their most of the stuff happens in the actual meetings, and because the meetings don't allow any kind of remote participation. You can't use phones, you can't use teleconferences during the meetings, so it's very hard. You have to actually be in, like the next meeting is in Hawaii, in Big Island, so you have to be there if you want to participate. But yes, if you send them to me, I can put them in.
Yes, cross-participation is so much more efficient. Thank you so much, Tero. Any question for Yach? Well, if so, perfectly in time, we will conclude this meeting. Any other business? Well, thank you all, and we'll announce the next series of interim. Recently we didn't do so many, so we'll work out. Probably would want one interim at minimum, and we had several drafts which were not really discussed yet. So we'll probably announce an interim. We have to announce them several weeks in advance, so you probably won't see them before September. Okay.
I'd like to thank Dominique for jumping in on such short notice. Thank you, Dominique.
It was a pleasure. Thank you, Tom.
Okay. Meeting adjourned. Thank you very much. Bye-bye. Oh,
Bye.
blue sheets. I want the blue sheets. Who has the blue sheets? Everybody signed the machine. Vous êtes serein? Vas-tu faire des champions? Ah, moi, je suis